Hello, everyone. I'm Professor John Nguyen, and welcome to Chemistry. For today, I would like to show you pretty much everything about solutions, from definition to concentration, dilutions, and some other calculations. All right, let's get started. Okay, in here it said read Unit 5 for more information, but actually, we're going to talk about it. So, for this one and probably another two videos, you will have enough information to do your homework and uh, good enough for the test. Okay. All right. A solutions is a homogeneous mixture of at least two items. One is the solvent, the one that's doing the dissolving, and the other one is a solute that's being dissolved. And you can have one or more solute. Okay. For example, you make a uh, salty and sweet solutions. Like you use water to dissolve salt and sugars. Those are your two. Salt and sugars are solute, also known as active ingredients sometimes, and water is your solvent. Okay, we got a few examples here for you. Carbonated water. You got carbon dioxide in water. Your solute is carbon dioxide. It's a gas. Seawater, you got sodium chloride, which is salt in water. Solute is your sodium chloride, that's table salt. It's an ionic compound. Sugar solutions, you got sucrose in water. Your solute is sucrose. It's a molecular solid. You got rubbing alcohol, in which we have isopropanol in water. Your solute is liquid, isopropanol, okay, and your solvent is water. So the point of this example is that your solute can be a gas, an ionic solid, molecular solid, or a liquid. Okay, your solvent too can be in any physical states. Okay, that you chose. It could be a gas, like air. Okay, you got oxygens and nitrogens. It can be a liquid. It can be solid as well. Okay, like alloy. Okay, like brass is zinc and copper. That's also a solution. It's a solid solutions. Okay, so it can be any physical state uh, of matter that you want, solid, liquid, or gas. Okay, let's talk about concentrations. The popular concentration that we see every day in everyday life would be the percent concentrations. We see that all the time, like vinegar is 5% acetic acid in water. Okay, and here it is, percent m over m, meaning mass over mass. So you would take the mass of the solute in gram, you divide it by the mass of solutions, the whole solutions. Solution is solute plus solvent. Okay, you add them up together. Okay, and so you take that, you're always going to take that ratio. Solute always divided by solutions and multiply it by 100. Okay, now this means your percent concentrations can never be more than 100. All right, because solute is always less than the mass of the whole solutions. Now you can do mixed match, like mass of solute in gram divided by volume of solution in milliliters. And that's easy to determine the volume of the solutions. When you mix your solution, you got your solute in the solvent and mix together. You can always transfer that into a graduate cylinder and find out what the volume is. Okay. The mass of solute, you can always weigh it using a balance. Okay, in the lab. Okay, so you get that mass of solute divided by volume of solutions, and then you time 100. Okay, the 100% here it's actually you mean you time 100. If you think about 100% equal to 1, if you multiply it by 1, that's not going to get you anywhere. Okay, so just 100. Save the percent sign. That's going to be the units later. Okay. Volume, you could do volume over volume. Like if you have a liquid solute, like isopropanol, okay, it's easier to measure the volume divided by volume of the total volume of the solutions. Most of the time, volume of solution will be the volume of the solute plus the volume of the solvent, the two substances that you mix together. Assuming there's no interaction, there's no special interactions, the volume should be add up, okay? And then you time 100, just not 1, okay? Save that percent sign for the unit when you're done. Okay, and here it is. Remember, mass of solution is mass of solute plus mass of solvent. And in most cases, the volume gonna add up too. Okay, now that's percent mean multiplied by 100. Now if you do part per million, which is ppm, is part per million, you do the same ratio, except this one we're just gonna deal with mass. And you can do with volume as well. Okay, remember mass has to be in gram and volume has to be in milliliter. It's just to make it simple. So you divide the mass of solute divided by mass of solutions. Okay, so solute on the top, numerators, solutions bottom, denominator. Now, because it's a part per million, you multiply it by 10 to the 6, which is a million. Now, part per billion is the same setup. Instead, you multiply it by 10 to the 9, which is a billion. Okay, so let's get through the concept and then we'll do some practice in a bit. Okay, molarity is defined, it's a different concentration. It's defined as the mole, number of mole of solute divided by volume in liters. Remember in the previous chapter 4, we convert gram to moles, and that's exactly what we need. Rams divided by molar mass, we get the moles, okay? Volume, if it's in milliliter, we just have to convert it to liters, okay? Divided by 1,000. All right, so that's when you get that ratio, put in the calculator. When you get the numbers, you will get what we call molarity. And again, we'll do some calculations in a minute in the next video. Molarity, for us, let's skip this one. We don't really need this one for now. This is a very special concentrations. Instead of volume of solvent solution, we do kilogram of solvent. And this is used for a very special calculation. It's called colligative properties. Okay, so we're not responsible for that. Okay, it's good to know, but not for now. Okay, now I'm going to move on to the ion concentrations. When you have an ionic compound and that's composed of ions. For example, sodium phosphate, you got 3 sodium ion and 1 phosphate. Remember to keep phosphate together because it is a polyatomic ion. Now, let's say we're given a molar concentration, which is molarity of sodium phosphate is 1.5 capital M. Capital M stands for molarity. Now, the concentration, if you want the sodium, so if we consume sodium phosphate, we actually consume a lot of ions because there's 3 times. So you multiply it by 3. So that's like triple the concentration, 4.5 M. But the phosphate stay the same because there's only 1 phosphate. Okay. If you add up the total, it will be 4.5 plus 1.5. That gives you 6 molarity total. So for ionic compound, like salt, when we eat salt, it's actually double because you have 1 sodium ion and 1 chloride, Cl minus. So the ion concentration will be double, and that's why when we eat salt, we feel thirsty. We have to drink water to get the concentration down. Okay. Dilutions. We will be doing some dilutions, meaning adding more solvent to make the solution more diluted. The nice thing about it is when you multiply the initial or before molarity times the volume before, it will be equal to molarity after dilution multiplied by volume, okay, total volume. It works for other units as well. We use M for molarity, but it's also work for percent concentration or ppm or ppb, any concentration as well. That's what we use C in this case for concentrations. Okay, and then the last topic in this chapter is osmosis. It is a process in which solvent molecules move through a semi-permeable membrane, which is a cell membrane, that only allow the solvent to move in and out, but not the solute, not the salt. Those require special gate, okay, special channels that move the ions across the cell. So cell is pretty smart, okay, and and that's the force, the pressure that push that movement, you know, um, it's called osmotic pressure. The process is called osmosis. Now, when you're thirsty, you drink water, okay, and when you drink water, water has to move into the cell, okay, and that process is called osmosis, and it take a pressure which is called osmotic pressure to move um, to move that solvent across, or to prevent that osmotic flow. Okay. Now we need to know the difference between isotonic, among isotonic, hypotonic, and hypertonic solutions. Iso mean balance, like when you um, drink something, it has to be balanced. Like salt has to be 0.9%. Hypo means low. So we cannot just keep drinking water all day without eating, without um, intaking salt or uh, energy, sugars and proteins and everything else. Hypo means low, hyper means too high. If we drink salt water, that's too much solute. We're going to be thirsty. Okay. 0.9% is a good isotonic, and 5%, 0.9% salt, sodium chloride, or 5% uh, glucose. Those are the standards. Those are the isotonic solution. The cell will feel comfortable with that. Anything lower than that, 0.9% salt or 5% sucrose, which is sugar, anything lower it will be hypo. Anything more than that will be hyper. Okay. And all right, in the next video we're gonna go over uh, some of the practice questions, okay, in details. All right, electrolytes, you probably heard about electrolytes. The electrolytes are essentially ions, and if we have an ionic compound that will in water, it will make a lot of ions and it will conduct electricity. So we call them electrolytes, and those ionic compounds will be very strong electrolyte in water. Um, non-electrolytes are like sugar, oil, those are more for energy. Okay. Weak electrolyte, like compound that don't make a lot of ions, like acetic acid, that's vinegars. Okay, that's weak electrolyte. It does make, but not a lot. Okay, and a couple other detail, knowledge, little thing, concept here and there. Like water is a good solvent because it has special hydrogen bonding that's interact with the solute to make the solute soluble in water. And one last thing, um, it's about solubility. Um, Solubility is the maximum amount of solute that can be dissolved in a given amount of solvent at a temperature, specific temperature. because when you change the temperature, you can change the solubility. For example, solubility of sodium chloride, which is table salt, is about 35 grams. That's a lot per 100 gram of water at regular room temperature, 25 degrees Celsius. And for most solute, the solubility increases with increasing temperature. Okay, so if you raise the temperature of water to 100 degrees Celsius, which is the boiling point, you increase the solubility to about 39 gram, which is not much, but it does increase. So when you make a solution, um, when you make a drink, you always warm the water and then you put in your ingredient and then you mix and then you chill it. Because you don't want to do the other way. If you chill your water, you're not going to be able to add dissolve um, much of the solute or the active ingredient. Okay. Um, Now for gas, it's different. For CO2, as a solute, as a gas, you definitely want to make it cold. Otherwise, CO2 will not stay well in the solutions. Okay. All right. Thank you, everyone, and hope to see you in the next video.